Hi, my name is Ayush Agarwal, and today I'm going to be presenting a paper on American Sign Language translation using deep learning. So, today in North America, there are approximately 500,000 people who use sign language as their primary source of communication. However, people using sign language find it extremely difficult to communicate with others, and this limitation can cause serious problems for matters such as hospital visits. Currently, interpreters are required to enable communication with others, but this can be expensive and may not be easily available. Therefore, the purpose of this study is to build a machine learning model using deep learning that can translate American Sign Language with no manual intervention. So, a bit of background research. American Sign Language is a language composed of hand and facial gestures, and it has many attributes similar to English. However, it has a different grammatical structure, but still consists of its own dialects and accents. Existing research in the field of sign language translation involve using sensors such as motion sensors, electromyography sensors, and kinetic sensors. Research using computer vision relies on using cameras to take pictures of people signing. However, most studies build models to classify numbers, alphabets, or words, and very few attempts have been made to construct actual full sentences. So I've been talking about machine learning or deep learning, and an important model in machine learning is the artificial neural network. And it basically mimics how a human brain works, and it consists of nodes which act as neurons, organized in layers with an input, hidden, and output layer. And the weights between these layers, denoted by the arrows in the diagram on the right, are used to estimate outputs given certain inputs. And the objective of this model is to determine the weights, which will minimize the loss. So deep learning is essentially just using multiple hidden layers in order to enable a neural network to learn complex features. A CNN is a special type of neural network that's extremely useful in image-related tasks such as image classification, object detection, and image segmentation. It uses various filters to convolve or slide over images and extract features from them, creating feature maps. It uses pooling layers to reduce the size of the network while conserving important information. A typical CNN consists of a structure shown on the right with multiple convolutional layers and multiple pooling layers, followed by a fully connected layer. So in this project, the procedure I used was the following. I first collected ASL data on 100 words using the WLASL dataset. I converted these videos to frames and created datasets out of them for my training, validation, and testing datasets. Since I was using a TPU using Google Colaboratory, I needed to create distributed samplers and data loaders for each of the datasets. I then defined my 3D convolutional neural network using the I3D structure built by DeepMind. I then trained the model for 20 epochs and evaluated the model on the test dataset. So this shows the inception module of the I3D model, which is an important block of it. It consists of taking input, such as an image, and doing several different convolutions on it, and then concatenating those results of the convolutions, and passing that into the next layer, which can be another inception module. This helps build complexity in the convolutional neural network. So in my dataset, I had a total of 2,038 videos, with most of the videos being in the training set. Here we can see an example of a video from my dataset for the word book. Here we have one of the signers making the sign for the book by opening and closing her hands. So the image below shows the 100 ASL word that I used in the study. And after training my model for about 20 epochs, the model had a mean cross-entropy loss of 2.0487 and a mean accuracy of 47.73% on the test dataset. So although the loss doesn't provide much information, the accuracy tells how many predictions the model got correct out of the total number of predictions it made. So as we can see in the table below, the training had an accuracy of almost double that of the training set, indicating that the model was overfitting. Here we can see a graph of the losses of the training and validation sets while the model was training, and again we can see how the model is overfitting because the validation loss begins to plateau while the training loss continues to decrease. Similarly, here we see the validation loss plateaus while validation accuracy, begins to plateau while the training accuracy continues to increase. Again, a sign of overfitting. So, although overfitting can be a a bad issue for model generalization, it can be solved through a couple of different ways. First is model regularization. Second is image augmentation, such as rotation, flips, and cropping, as shown on the right. And third is increased data size, so that the model is always seeing new images rather than the same one. So, to conclude, today, hundreds of thousands of people can communicate in only sign language. The majority of people, however, don't know how to speak in sign language, and this creates a communication gap between those who can only speak in sign language and those who cannot. Deep learning, however, has shown itself to be a useful tool in various tasks. The study illustrates how deep learning can be a promising solution for sign language translation. Although the CNN model designed in this study didn't achieve a very high accuracy, it was still able to learn from the videos and translate between ASL and English. Still, there is more that can be done for future studies. Further study can be done in experimenting with the CNN model structure, trying to increase the data size by adding more frames in order to improve model performance, and also experimenting with different loss functions in order to try to optimize the weights. If more research is done in this field, deep learning can prove to be revolutionary in the field of sign language translation, and if successful, these models could significantly benefit millions. Thank you.